Okay, welcome back. Last night I left off telling you about Sigrok packaging and stuff. Well, I am testing it out and I got it all working. So, first of all, the package isn't everything. So if we go into archives here, there we go. So I copied this over to a Raspberry Pi. So I have here, and I'm just going to show you with my little wireless cam. Okay, so that guy there, Raspberry Pi 4. It's hooked up to a little panel so that I can see what's going on it. But I am actually VNC'd into it. There's the Sigrok, the Cypress FX2 hooked up to that Raspberry Pi. And I set up a little test board here on a Pico, just cycling through some LEDs. And as you can see, I have signal wires, acquisition wires hooked up to it. So I'm just going to turn this camera back off because it eats battery life like you wouldn't believe. So once I put everything into the Pi and I unpacked it, and we are going to go to the Pi, SSH Pi 192.168.42.218. So there's our SR directory right there, and I unpacked it. It didn't run. It complained about boost libraries and other crap like that. So what I ended up doing is going back to here to the instructions for building it right here. So Linux binaries building. Now I didn't build it again, no, but what I did do is see this apt-get install all this crap. Yeah. And then apt-get install all this crap. Yeah. And then again and again. I just basically dumped every library they were using or trying to attach to into the Raspberry Pi. And after I did that, I added one more, the SDCC, which is not seen in here, but you need it. So once all those libraries in place, I solved the libboost problem. Okay, that left. Okay, I've got it in. I need a shortcut to start this. So right now I do have one here, but I didn't have that before. So if you look in the SR directory, under share, under applications, you see the desktop linkages. If we look at one of these guys, Sigrok Pulseview, for example, they make some assumptions. They make, for example, on the exec and the icon, they assume that it's on the path somewhere. But since we're running everything in our custom little directory, this won't do. Okay. Now on a Raspberry Pi, if we go into user share, I think it's there's an application override directory basically. And I had to look this up on what was it? Creating a desktop icon. Yeah, user share rasp p UI overrides. And then into applications. So these guys. So I created I moved the org Sigrok Pulseview desktop into here. Sigrok. So like so. Now when I created all this, right? Sure, it created the icon and everything and put it into my menu, but it wasn't the final copy, so to speak. So once it got one, it actually made another copy. And in .config here, and Sigrok, I think it was. No, not that one. CD into oh, where was it? And there was a spot where it was putting it. CD local. Yeah, okay. Share. And then applications. And there you go. So copy the copy over here. And this is the one. This is the one that controls the one that's actually in the GUI. And I found out where I had the exec and I had the LD line and everything, just like I have on my Intel/AMD side, it didn't work. It always bitched and complained and said something's wrong with the whole file. And that's a really annoying thing, is that one little error in here, it doesn't tell you where the error is. It just says the whole file is problematic. Punk. So I tried to fix it, got annoyed with it, and what I ended up doing here is I just went into the directory, created a shell script to actually run the LD line space, the Pulseview thing, just like I would do if it was normally here. And that worked like a charm. Fixed the problem. Pointed at the icon, usual stuff, yada, yada, yada. Okay. So now when we go up here to our little VNC and Pulseview, we go properties on it. There's the entry. So working directory, I had to put that in. It didn't like it if I didn't do it. Then I did this. That solved the icon launch, but it didn't solve the starting of the program. That was one more problem, and that didn't happen on the Intel side. And that had to do with SR, I think it's lib actually in this case. No, is it include? Or is it is share? Yeah, Sigrok firmware. So these are all the firmwares for different devices. In our case, we happen to need this firmware right here, the Cypress FX2 firmware. Problem was, it couldn't find it. Yet on the Intel side, I had no trouble. It found it. Even though on the Intel side, I haven't installed the package Sigrok firmware. I go here and I go apt cache search Sigrok. So this guy right here, and we go show. This guy right here, package all extra origin meter. Blah blah blah. I don't think I have this installed here on this side, but it's in the SR directory. And this side it works. I can actually check this. Yeah, see, I don't have Pulseview in here. It doesn't exist. Or Sig. See, no Sigrok. But if I go over to here to down here and I go Pulseview, it runs no problem. And I know I've loaded the Cypress board up on this, but on the Pi it wasn't doing it. So one more app to install on the Pi. We end up doing simply installing that firmware deb package. At first I thought it would go into because normally firmwares are in lib firmware like so, and you have all these firmwares in here, and I thought, sure, I put the Sigrok firmware here. Look at that, they're all there. Nope, didn't work. For some reason, it didn't like it. User local here. Don't see it in there. User here. No. There. See, it's looking for the damn firmware in the wrong area. User share Sigrok firmware. Dumb thing. I mean, that's someone who's built this, put the parameters in this package. This is not where it's supposed to go. But it solved the problem. If you had to manually do it, you could create that directory there and populate it with the firmware file. Or you could probably make a link to your one and your home tree back to here. But you probably have to do it as root. So that all got put in place. And then again, when I ran it, ta-da, Cypress right there, FX2. So next stage of the thing, test it. So now one thing on this Sigrok board, when you look at all the little parts, it'll say P, D, P, B, and PA, but no PC. So what you have in here is PA0 through PA7, then PB0 through PP7, and then PD0 through PD7. Now the trick is, this calls them D0 here. What is D0 over here? Well, it turns out PB0 is D0 over here off the Cypress board. So PB is actually the first set over here. Okay. So what I've done in here is I've gone into the settings for this, for pins, and I've only turned on the first 7. In fact, I'm only using 5 of the things on here. I could actually go like this. 0, 1, 2, 3, 4. So remember, since we're starting from 0, this is actually 5. So if we go like that and we say 1, 2, 3, 4, 5 probes, 5 LEDs, and if we go to here and we open up the workspace for this in CircuitPy, open. Okay, so what we have here is I took the standard Blinky program and I extended it. So I knew on the Pico, and I have to blame these guys for one thing. If you're going to put this little board, and let me show you the board again. This board, like so, and you're going to put it down on a breadboard like this. You have the reset button and all the outlets and that. Why in the frick did you put the labeling on the bottom? That I found so. If you're ever going to buy these things to play around, buy at least 2, right? Or have your little card for the thing, so that we can know that this pin over here in the corner, where my finger is on, is actually turn it around so that the end is like that. This one, this is GP15 right here. So GP15. And since I have this board and it's oriented like this on the breadboard, all the LEDs are coming off this lower section right here. So basically GP 15, 14, 13, 12, and 11. As you can see, I'll bring up the desktop again. Right here. So I mapped out LED 1, 2, 3, 4, and 5. And then down here, I just cloned the default onboard LED, which is this one. And 1, 2, 3, 4, 5, and I put it at 0.1 second pulse. So the lights are pulsing. Okay. So we come up to here, and this is sitting at 1 million samples at 20 kilohertz, the default. If we go and run this now, every time a light pulses, ta-da, Now you could zoom in by just scrolling the wheel. You can see some interesting effects on the pulses. But there you go. That's the idea. And the reason for the staggered is you notice that this pulse here, and then this pulse here, like so on, is like a staircase effect going slightly ahead. That's because we are not simultaneously blinking all the LEDs. So we are not sleeping them all, like turning them all on simultaneously and then turning them all off simultaneously. Right? But we could see in here, if we change the code in here, so we happen to have, let's take out the, no, let's just leave that one. Let's go to LED 1 and we'll change the timing to 2 and save it like so. We'll run our thing again. Now you can definitely see the change in the duration here. Not much, but it is a change. So let's really make a change. So stop this and come back over here. Instead of 2, let's make it 4. And we'll run our thing again. There we go. Now, the idea behind this, that we're just doing pulses of a thing. Now, since we are changing the time on the sleep value after it turns on, that's why you get a continuous solid bar here, like so. On the other hand, if we were to leave the false value and at 1, just the true value at 0, we can see a change in here. We'll stop this and we'll run it again. See, the widths are changing. But you get the idea. It's the whole point of a thing, single analyzer. Now, if we were to hook this up to a CPU, we could put our acquisition lines, for example, on the address lines, 0 through 8 on a 6502, and we can actually see what goes through the address lines. Or, and I haven't tried this yet, I could put this on an I2C, I squared C signal, use the decoders. Just a sec, stop. Now I haven't tried this on here. Oops, stop. There we go. Okay, so here's another problem. I hadn't tested this out on the Raspberry, but I'm missing all the decoders, which is not good. So, not sure why. This is not 100% perfect yet. And I suspect it's because things aren't installed where it thinks it can find things. Even though I've told it about the SR, but there's that libsigcode decode library. We come back to here and we go back to the building tools. I expect, oops, not that. This one. I suspect when we come back here to before Pulseview, not the CLI, this guy, libsigrok decode. Right there. Right? We're missing it all. For some reason, it's not there. This should be populated with a list. So we know it all works, and it kind of works on the Raspberry Pi. I'm going to move the decoder over to my main machine instead. So Goodbye app. We don't need you. I think I'll close you off. Yes, saved and save data. And we won't worry about the Pi for the moment. It can go. And instead, we unplug it from the Pi. And we plug it into here. Now we check. Right there. Do a D message. Not quite. So let us not quite showing up. Did I get the right cable? Just put these over here. Okay, so right cable. Dun, dun, dun. Dun, 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 dun. Yeah, we do have the right cable. For some reason, it didn't pick up. Let's try again. Let's just check with Pulseview over here, see if it picked up the Cyrus. Yeah, it did. Okay. So it's there. Okay, so we're going to tune it over here just like we did. So we'll take none, D7, D6, and D5 off, like so. And we'll just run it. Okay, so stop it. And I think I wanted on this, there's a configuration thing for this. No, not that one. Zoom to fit. Okay, let's run it again. So we know. Okay, so stop it. Views. Constantly perform zoom to fit in. Yeah. Okay, let's try that. I think that's what I had before. Okay, stop. Now in this one, if I go to here, see, this list is populated, all the decoders. And if we go I to C, integrated circuit I2C, we can, in theory, debug the I2C bus. And it should decode it and show us what's going on it. And of course, we can go back to here. Now, where's our this? So we changed the timings to 4 on 1. Now, what we also can do here is we come along. So turn it on, turn it off for 0.1 seconds. We turn it on. What we could do in here is just go like this. And let's change this a little bit so that it's simultaneous. So we'll take that out. And see LED 2 value true. Take that one out. And then we take 3 here. Control C. Control V. And we'll take 3 out. 3 true out. And we'll take number 4. Control C. And we'll do 4. So 4 true. We don't want that. Okay. We want number 5 true. Control C. So we come along. We turn them all on. We will sleep. Control C. And then okay, so we come along after the onboard. We turn 1, 2, 3, 4, 5 on. Sleep. Then we turn 1, 2, 3, 4, 5 off. Sleep. Now the LEDs are blinking simultaneously. So if we come back to Pulseview here and we run, there you go. So now you can see they're all simultaneous. Doink, 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 doink. Ta-da. Oh, help. Doink. About. There you go. Pulseview 050 from Git. I found the help hidden away. Firmware search paths. I didn't notice this before. Okay. Firmware. Oh, well, share Flatpak sports share. Well, that's weird. I mean, that could be the problem right here in the Raspberry Pi's version. Is this some of the stuff is not where it's supposed to be. Protocol decoder search path. Aha. Right. So right there, this is what I missed on the Raspberry Pi. That section right there. That would fix the Raspberry Pi's decoder list. So by default, I think on the Raspberry Pi, it's not that way. Let's go to Remy for a sec here. And we'll connect. And we'll make this bigger. Yeah, something like that. So when we run this one over here, programming Pulseview, and we go here and we go about root sr share lib Sigrok. Oh, that's why we're having the issue. It's in the wrong directory and I can't read that directory. That's the problem. And that's why the firmware is borked also. I built this in the Docker container as root. I should have built it as a user. Okay. Yeah, that's what happened. I wonder if you sudo this and ran it as root, that would fix the problem. But yeah, okay. That's why the firmware didn't work, and that is why the decoders aren't working. They're in literally the wrong directories. But there is an environment variable that says that. So let's copy this. Copy. And we'll just exit out of here, and we will exit this. And we'll go here. And we'll go into SR bin. We will buy the Pulseview.sh. Open. And we will say, oh, I really hate that when it does that. That's set mouse minus equal A. Stop that frickin' visualization. Paste. Equals home. Pi. And we need to know the path where it's going to be. I need to start this again. Okay, so about SR share librock decoders. Okay, let's just do this part here. Okay. And we will go back to console here. And append, paste, like so. Oh, come on. Is that file pi root? No, it's pi. Oh, I hate that when it does that. Where's my console here? CD SR share, no, bin. And we'll fix it from here. By Pulseview.sh tilde. Open, insert. Nope. Set. I have to do this in a more permanent manner. Maybe. Whoops. Fuck off. Insert. No. Colon set. Mouse minus equal A. Insert. Paste. Home. Pi. And we need that variable. This one right here. Copy. And back to Mr. Console. Paste. Equals. Like so. Okay, move. .sh tilde to sh. Like so. Okay. Now go back to this guy here. Close here. Close here. Oops, close this one. There we go. Whoops, what did I do? Oh, I closed my room one. Okay. Window. We don't need this pulse view. Close it. Close it. And we want to adjust the launcher a little bit because I had it on debugging mode. Properties. Don't need this. Okay, I don't think I need this. Okay. Well, no, decoders are still not being found. Okay. Um, uh, oh, William, quit. Insert support. Let's try this again. No, no, it won't let me do that. Oh, not from here. It won't let me do that anyway. Um, let's try this again. See if this works. There we go. There we go. Decoders. Now we have decoders on this side. So I'm probably going to have to go back and rebuild the. Now that I know what I have to fix, I can rerun the Docker, rerun the whole build process as a user. But I don't like that hard encoding of paths into the thing. That's not very good. All these paths are linked to choose a lot. Look at all these paths. Firmware search paths. All not good. You think that homepi.local share Sigrok firmware would be there, but I didn't remember seeing that. cd.local share. Yeah, see? Go back to here. HomePi, local share. There's no Sigrok firmware directory there. Okay. Supposed to look for one there, but it doesn't see it there. So in theory, ln minus sf $ home sr share and ssh pi at 192.168.42.218. Yes. CDSR share Sigrok firmware PWD. So yeah, so we need to stack this on the end of that. That's not quite right. That didn't work. RM. Let's change this to a little bit. Home. That's better. Sigrok firmware. Okay. So we know that this version here, RM minus RF Sigrok. No, sorry. CD firmware. RM minus RF Sigrok right there. Oh, I'm not root. CD lib firmware. RM minus RF. Sigrok. Good riddance. Apt. Remove. Sig. Yes. Okay, so let's see if this runs properly now. Close, close. So now we're pointing to the firmware in the home directory. It doesn't exist as a global. And let's see. Yep, no problem. Yep, no problem. Now, in theory, if we unplug the Sigrok now from there, go back to the Pi, put it on the Pi, like so. And we close this, Pulseview, just open it up again. There you go, Cypress FX2, right there. And we go none. We don't want that one, or that one. Just like so. Close the pinouts and we run it. There you go. Ta-da. All works. And of course, that's all there too. So probably going to rebuild this again when I get a moment to fix the path issue for the decode. In this case, the path issue on the decode. So firmwares are all correct in here. Yeah. That's interesting. Home will MSR share decode. You think it would find at home will MSR share Sigrok firmware on the Raspberry Pi, but it's there, but it didn't find it. So something's quirky with the paths. But that is the Sigrok. All working. So now we can actually take it to the next step. Actually analyze something more than LED lights going on and off. As I mentioned, I have CPUs, Z80s, 6502s. And what we want to do. Now, I saw some interesting code on a site that was combines this idea, but not this board, with a Arduino Mega and be able to, on the fly, decode 6502s, basically all the pins on it. Kind of like a interpreter. Let's see here. We don't need that. We don't need that. We don't need that anymore. Yes, I have to clean up tabs. Okay, what we got here? Getting started with Docker. New tab. No, we don't need that. I'll leave the build up. Yeah, so this sort of thing. 6502 minimal computer with Arduino Mega Part 1. So this guy here is very similar to what this is here. This idea is the same idea. We're actually watching things happen on 6502. So you have these address lines here and you have these data lines here. So we have A0 through A12 address lines, and then we have D0 through D7's 8 bits data line, right? So the real trick here, of course, is First thing you have to do with any of this on the 652, you got to get a clock working. So make a clock. But that's that. And then someone else, the Acme of Foolishness. Yeah. This is making your own Apple One replica. Right? The reason for the solder job here is what he's doing is he's playing around with this section right up here. The 36 through 34, probably 34 through 38 or whatever pins. If you short one of these pins out, for example, you send a NOP signal, so you actually loop the CPU for a while, until you pull the power or whatever. So that's kind of the idea what's happening here. It's a trick to kind of boot your computer, but not boot your computer. And this guy has a whole tutorial on building a 6502. Clock module, Keystone C, basically. And you don't need much parts to do this. Now this here, he's basically decoding the 6502 in action. So now there's another one called what was it called again? Do I have the bookmark for this? Other. Let's see. Veronica. That's what it was. Veronica Apple. And what we want here is her page. No. Apple one. I think it was. No, not Veronica. Good old Google. Apple. Where does pancakes come into all this? I don't know. Apple emulator. There. This is the one. Blondie hacked Veronica. So this is the start of it. And she goes through all the processes of. Now, this guy up here, this decodes the address lines. So you can see it's kind of plugged in. And that's a clock generator on the right. Of course, a power supply, custom built. But there's the actual clock chip right there. So, and you can actually, there's more pages. This is just page one. Let's see if we can find the index of pages here. There was an index of master pages that, okay, ROM emulator. Okay, there's the interesting part that I was interested in. Let's just back up here. The hex out. Building this. Now, this person went to all the effect of actually customizing this. So if we go back to page 1 of this, so she even built the board, she custom etched it, the whole 9 yards here. X out to, and then we scroll down. And we're going to go to page 1 first. Okay, 16x. So there's her little circuit diagram, and she's using basically a very common IC. Where is it? Files on PP. So there's the board that she made. It's actually 2 boards. 2 or 3. Okay, so she builds the board. She hand wires, he or she hand wires everything. So testing it out. Yeah, building a 3-layer module that displays the values of a 16-bit bus in a human-friendly way. So this is the next section. Oh yeah, here we are. 75HC 595s, which I do have. So there's our next PCB. Now I'm pretty sure one of the sections of this could probably be done as a double-sided board and just get one of the circuit board makers to PCB makers to just spin off a few of them for a few bucks. Because otherwise you have to have the chemicals and everything to do this, right? And so last piece. So a little toggle switch. That's the display, I believe. No, those are the 2 7400s. So yeah, so we have the digit displays, the ICs, decoders, and then so that's the thing that plugs into the edge, where I think the ribbon cable goes onto it effectively. Yeah, so that's the edge connector there. See, I think I would clean this up a bit. I would look at a method for doing those displays without needing all that wiring. I mean, the other thing you could probably do with this is, do I have one handy? So for example, here, let me just get rid of the browser, the desktop for a sec. You could be doing this type of idea. See, off this instead of that right there on the on hers. So let me just move this browser slightly so you. So we have this from AliExpress, for example, 8-bit LED digital tube module, basically. There's some of those drivers on the back. This is really no different than the LED matrix, guys, except it's just digits. But this would be a cleaner job. You could probably do this in 2. So this, for example, is a bigger one with grid. Now that's that. And don't I have, I should have somewhere around here. Let me just check in this bins. Nope. No. Where do I have some? Ah. So matrices. Here we go. So this is a multi-row thing, but you can program it through this little board on the back through 4 wires. Period. That's it. And you can have complete display on it. So I've got a couple of these things, for example, right? That's one. And then another way of doing it is a narrower one. So see, big, little guy. And again, this one here, I drove it all over and I think this still works. So let's see. Just move those over here for a sec. Now, do I have... Yeah, so we're going to just kill our little logic probe thing for a sec because we need its cable. And I'm going to put it over here on here. And we will just plug it in. I don't think I've done anything with this, but it should still work. Let's find out. Yeah. Here, let me turn the light off. There you go. You can kind of see the digits. See? 2 rows of digits programmed through a little Arduino Nano. So that's the idea. I think most of this can be done through an Arduino and a digit display like this. So we would have to basically acquire the data. So we have here on hers, on this part here, let me just make the screen bigger again. So you can see on hers, or his. So we got 1, 2, 3, 4, 5, 6, 7, 8, 8 and 8. 2 sets of 8. Okay. So 16 pins. Now this is where an Uno style board with, let's see, 0 to 13 digital and 0 to 5 analog, but it can be reprogrammed. In theory, a board like this, and you can't see it, but in theory, a board like this one here, this Metro, could do it, but better off would be to use a Mega. Because Mega's got gazoodles of pins and use one. That's why they're probably doing it for the Apple emulator. But yeah, I wonder if that just controls brightness. Yeah, it does. But yeah, so this little guy here combined with an Arduino 2 with the code on it. And if you did it on the Metro board, for example, I have the the Grand Central, right, with all the pins on it. You could do this all in CircuitPython. So you would hook up your 16 pins to data acquisition pins to maybe something like these red gizmos like so, and I have more of them. And then you could hook it up to that, or the other one you could do it on is easily the circuit Python stuff is on the Pico, because the Pico has tons of pins. I mean, we have 21, 27, 28. There's literally 28 pins on here for data. I mean, sure, pin 26, 27, and 28 are considered A0, A1, A2 analogs, but you can convert them. But just on pure data alone, we have pins, on one side alone here, we have GP0 all the way up to GP15, right? So in theory, this one whole side could be, the data acquisition side for reading all this. I mean, this would be a fun project to do, if you had the materials for it. Where's my mouse? There it is. This guy right here. But I don't have the etching tools or anything like that to make that. And I still think that circuit board could probably be turned into a one boarder, a single board solution instead of three boards. And of course, these three boards, I believe, are all single sided. Right? It was all through hole, but yeah. So, and then what he did is, the person did is he took that to help him decode the 6502s. So CPUs along with this, and then of course this. So the first thing is we need a 1 megahertz clock here, and this is what this diagram does. It just shows you how to make a 1 megahertz clock. Okay. Then he turns around, and this one is the 65 CO2, and I have a bunch of them. I think most of them are, 10 or 14 megahertz technically. So you hook the clock up, you did that, and you see that blue line right here on it? Well, what he's doing here is he's doing some address ignoring to hex out. He's taking all that and he's pumping it into the hex out thing. Now you can see here on the lower part where it says D0 blah 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 and stuff, how he hooks some to ground and some to short and live. Well, that is to get the CPU to go right away into NOP mode, NOP, no instruction. And basically, you boot the CPU. It's not really reading any RAM from anywhere. I mean, none of the RAM lines are really used, right? You can actually see that in here where the upper left of the CPU, the pins aren't connected to anything, right? So you can see that he's got all the address lines down one side of the CPU, plus the extras. Then the blue wires go around to the other side of the CPU and get the last of the address lines. Okay. So then let's see, ROM emulator. He does it step by step. So wow. I haven't really read this section exactly what's happening here and what he made here. But really, can we wow, that's a lot of soldering. A lot of wires and a lot of soldering, breadboarding. That's breadboarding. Then we get on to the back plane. This is like the slots on the motherboard and stuff. See? Designing for it. Makes a PCB. See, this is all handmade. Um, Usually what you do with this is you can use a photocopier, for example, to place the light blocking material on the copper, or you can use a inkjet to make it, or there's a number of ways of doing this. It's interesting to see. Again, that's a lot of soldering. I think there's a bit of a power supply for the slots. I'm not even close to this yet. Or like getting all the tools ready. But I'm sure I'm going to go the route of using an Arduino to do a bulk of the work because I don't have the tools and stuff to do this side, to build all these. There's a CPU board. Interesting. Oh, I see what you've done. So, if you've ever seen what's called an S80 bus computer, way back in the early 80s, it was just in the same era as the when the Apples were and the other stuff were coming out. The computer itself was on a card. So you had this big bus with all these slots, and you would stick the card on it, and that would be the computer. And you'd stick more cards for all the expansion. There's quite a. I remember reading in the back of magazines a lot of different S80 bus cards that you could get to stick on your S80 bus. No, why do you put all the blue tape on it? The prom programmer. Um, so he has the fancy logic analyzer hooks up to his oscilloscope. See the Rigel facepalm. Oh, what did he facepalm on? Okay. That's quite the switch in midair there. We're on board. So I guess he now figured out the ROM. He's building the ROM board. You stick onto that. Yeah, like so. New logo. Now that's a lot cleaner board than his first ones. Her ones. Getting a lot cleaner. Solder, solder, solder. You know, when you do stuff like this, it's all possible. If you're going to use these round-headed inserts for chips, you might as well use it for all of them. Because usually you can get from the suppliers like AliExpress or whatever, you can get all these in all sizes. So, you know, this is a four dip. This is a 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8, 3, 7, 7 dip, 8 dip. You just get them as that. I have found that the square hold ones, sometimes they bugger up when you're putting chips in them. They're just so chintzy these days. AVR Wi-Fi. Hmm. Oh, that's something different. I wasn't looking at that. Wow. But you get the idea. GPU interface. So she did do. Oh, I remember this part. She used an AT Tiny um, to help her a little bit in the Apple II thing. So she programmed the. Oh, this is her etching instructions. How she did etching. So there's a more complete. So she's made each one into a card that she subs onto the that board. But it's worth a read. But at the moment, I think I'm going to call it. I want to think of what I'm going to do next. Now that I got the Sigrok all working, except for rebuilding it maybe for the path issue, but I can work around that. Um, it is workable, so just a matter of figuring it out. Um, yeah, so have a weekend.